Let's talk about tests, test-driven development. We're going to have 2 lectures about tests. This one, lecture number 13, it's about test-driven development, the philosophy of testing, what it's for, and how it affects software design. And then the next one will be about test design patterns and anti-patterns, so how you design your tests so that your tests will actually help you instead of making problems for you. Let's start with this agenda. First, we're going to talk about the philosophy of testing, which I believe is super important for most programmers and testers. We don't understand how testing should be done. The second one is about test-driven development. I will tell you about what it is, how it works, how it doesn't work, because in my opinion, in most cases, it doesn't work, this test-driven development, even though it's quite popular idea. Then we talk about the difference between unit testing and integration testing. It's a not strict line, and there are many discussions about that, what we need to, what we can call integration testing, what is unit testing. Then a few words about test coverage, which is, in my opinion, a very important concept for testing. So if you do testing, automated testing, then you need to know what is test coverage, how to collect coverage, and why it's important for you. Then, super important topic, which I don't really know how to present and how we will discuss it, automated performance testing. I think it's still the area of a lot of unsolved problems here, but we still will talk about this. Finally, about behavior-driven development, also an interesting concept which is related to testing. Then we will talk about testing versus quality assurance, which is also a very controversial area where people make many mistakes. They believe that quality assurance is testing, and testing is quality assurance, which in my opinion is completely wrong. And then we finish with the books. I will suggest you some venues to publish, and then what to do next. So let's go, we'll make a break in the middle. So 45 minutes, we talk about philosophy of testing. One of my favorite topics, actually. This is not one of my favorite authors in the area of testing, which you definitely have to read. This is the book called The Art of Software Testing. It's a small book. You can read it over a weekend, maybe even one day. The Art of Software Testing. It was published, if I'm not mistaken, before I was born, something like that. It was like maybe, I don't know, 40 years ago or something. And it is now the 3rd edition. So the book has been republished a few times. The book tells you, doesn't give you really like code samples. It doesn't really teach you how to code, how to write tests, but it will teach you the right understanding of testing. So this is the quote from the book. One of the primary causes of poor application testing is the fact that most programmers begin with a false definition of the term, the false definition of testing. Most of us think that testing is the process of demonstrating that errors are not present. If you ask any average programmer or any average tester in any company, what testing is for, what are you trying to achieve? The typical answer is, we are trying to prove that the software works as intended. It works as our customers want. This is what they will tell you. And this is the fundamental problem of testing. That's what Glenford Myers says. We should not think this way. We should think differently. But he says that because we think this way, we have all the problems with testing. A more detailed quote and answering how we should think, he says, this is the same book, I showed you the face of the author and now the book, which you have to read. Don't test a program to show that it works. Instead, start with the assumption that the program contains errors. Your job, the testing, is the process of executing a program with the intent of finding those errors. So when you ask you, what are you doing? You're the tester, or you're the software developer who is testing. What are you doing? You have to say, I'm not trying to prove that the software works. I'm trying to prove that the software doesn't work. I'm trying to break the software to prove that there are errors, to show those errors. But he says that most of us think the opposite way. I've seen many presentations in big conferences where people start telling, like big guys, explaining about testing. They start with a sentence like, okay, here we are, we have the software, so now let's test because we need to show the good software for our customers, so our job is to prove that it works. No, our job is to show that the product is broken. This is the job of a tester, to prove that the product is bad. Not good, but bad. This is the psychology of testing, but it's difficult for a programmer to to think that way, because we don't really like to break software. We, especially testers, they don't like to get into the conflict with designers, and you will see that when you will start working in the real product, in the real company, with the real product. You will be the developer, for example, the programmer, and you will have a team of testers. And these testers, they will try to be good friends with you. So they will not be very comfortable telling you that your software is broken. But this is their job. So their job has to be to show you that the product is broken. You will show them the product and say, the product is great, that's just a new version, like check it out. And they will, in most cases, they will like to tell you that, yeah, that's cool, let's put it to the market. But they have to do the other way. They have to do the other job. They have to be more, more negative. They have to, not more, but they have to be completely negative about your product. And I don't give you the quote here, but I read in one book, then they say that there's a fundamental conflict between developers and testers. So developers, they look one direction. They want the product to be good. Testers, they want to prove that products are bad. And in this clash, in this intersection between these two directions, two vectors, the quality is born. So if we both look at the same direction, you are the tester, I'm the developer, you want to prove that the product is okay, I want to prove the product is okay. We both want the same. So what we're gonna get? We're gonna get missed errors. Because you're gonna overlook the errors. You will not be comfortable telling me that, look, I know a way how to break your product. I found another error. Give me another 5 minutes, I'll show you another way. No, you will be just, okay, that's not so important. Let's just put it to production. And then our customers will be the testers. And then you know what happens. So he's saying this, but most programmers don't think like this. I give you 4 quotes. No need to read them right now to every detail, but I quote 4 books. 4 books, 4 articles by famous authors who say that testing is proving that product is okay. So these guys, they say the opposite things. So they're wrong. That's why I put their names in the red color. So they, for example, take a look at the left one on the top. If something is to be delivered, then it's the testers who make the final decision of whether or not that something delivered to the live environment. So testers make the decision. Is it good or is it not good? Testers will always say it's not good. They need to be motivated to say, no, it's not good, it's bad, it's broken, give us more time, we will find more errors, we will prove you that is broken and broken. So the testers should not make this decision. Or take a look at the right quote, right top. Software testing is the process of executing a software system to determine whether it matches its specifications and executes in its intended environment. That's the paper which is called What is Software Testing? And then why it's so hard. That's the title of the paper. Why it's so hard. Why? Because you're saying this. So it's to determine whether it matches the specification. No, it should be the other way around. This guy is wrong. The job of a testing is to determine that it doesn't match the specification. And now show me how. So if you become the tester, and actually I believe, I said it many times in many conferences, that I believe that the work of a tester, the job of a tester is more difficult than the job of a programmer. So, and I believe the testers, they need to get more money and more respect than programmers. So programming is building. So you build, you don't care, work, it doesn't work, who cares? I just build it, put it to production. I mean, I push it to production, I make more features, I build. The testers, they are more, it's more sophisticated job because they need to find a way how to break what you just built. And if you're a good programmer, then tester has to be better than you. The tester has to be more professional, because if you can write the software which looks like a software without bugs, then the tester has to have a higher level of higher professional level to prove to you and to everybody else that your code is actually broken. So testing is not what they say. And this is not going to be in our lectures, in the slides, but it's a very typical question. Who decides when the software goes to production, to the customer? So if programmers say that we are happy, the software is good, I'm a good programmer, I write without bugs, I'm sure that my code works. This is the new version for production. The tester comes in from here and says, no, it's broken. Look, I'm even better programmer than you are. I found a way how to break it. I built some scripts around your software. I put it to some different computer. It doesn't work well. It works slow and so on and so on and so forth. So I found 10 bugs in it. And if you give me more time, I will find another 10 bugs. Just give me money, give me time, and I'll find it. I mean, pay my salary, I will keep finding bugs in your software. So I will, every day in the morning, I will say, no, it's not ready for production. So when will it go to production? That's the question. So at what point of time somebody will make a decision? Who is this person? So I believe, and it's not only my belief, is that that person has to be somebody who stays on top of testers and programmers, project manager. So somebody who is the boss of programmers and testers. So I'm the programmer, you're the tester. You want to say the product is bad, I want to say the product is good. Somebody on top of us, look at what's going on, and at some point of time, that person will say, okay, now the speed of finding bugs is getting lower. So I see that you guys are finding less and less and less every day. Okay, at that point of time, I say release it. So when we get a new version, I get it from programmers, the new version of code, I give it to testers, these guys are done, these testers start finding bugs. Of course, they will find a lot of bugs in the beginning because it's a new version, but at some point of time, the amount of bugs they find every day, it will decline. They will not be able to find the same speed. Well, maybe sometimes they even go up. So they will find a lot of bugs, like maybe more every day, and then we'll go down, down, down. At some point of time, I'm the manager, I say, okay, stop breaking this product. We give it to customers, let the customers continue testing, and let's try to test a new next version. So this decision is made by managers. So the manager has to balance between these two forces. One force is against the product, another force is pro the product. That's the philosophy, psychology of philosophy. Another quote which is interesting, also from the book, which you also have to read, Rex Black, a great author about testing. He says that software testing is not about proving conclusively that the software is free from any defects or even about discovering all the defects. Such a mission of proving that there are no defects or discovering all defects, such mission is impossible to achieve. So we know, we discussed that already, that any software has unlimited number of bugs, and it's impossible to find all of them. And giving this job to the testing team and telling the testing team, please find all the bugs, just the task which doesn't have any sense, because we know that there are an unlimited amount of bugs. That's what he's saying. A few more quotes and we're done with the psychology. Another one, they also very good book. They position it from the from a different angle. The immediate goal of testing is to find errors at any stage of software development. More bugs discovered at the early stage, the better will be the success rate of software testing. They call success rate. And you know what my understanding of a properly organized testing team is when the tester, just be prepared for that, when the tester is being paid for each bug found. So in ideally perfectly organized software group, I would say you're the tester, you get $10 for each bug you find. You don't get the salary, you don't get anything. Okay, you get $100 for each bug you find, depending on the complexity of the software. So every time you can really break the software, you can prove us, for example, we are programmers, you're the testers. Every time you prove me that my code is broken, I give you $100. So I don't pay you the salary, I don't care how you do it, I don't care how much you spend time on this, I don't care what software tools you use for that, I don't care how big is your team, you can hire 5 friends to help you out. The moment you prove to me that the product is broken, I give you your money. You know this very famous author, Donald Knuth, who wrote the books about programming. He, at the beginning, when the book was first on the market, he promised, if I remember correctly, $300 to $27.67. $327.67. That's the 2 in the power 15. So it's about $200 for each typo, which somebody will find in the book. So he was so sure that the book is great that he said, okay, you find the typo, you send me the typo, some mistake in the book, then I give you $300. And some people found those typos, and so he sent them the checks for this money, for this. So he didn't say, please review my book, I will pay you $300 if you review my book. No, don't review, I don't care about your review. I only care the problems you find. The same should be for software testing team. I don't care how much you test, because in most cases, in most teams, they will pay you if you try to find a job as a tester. You will tell you, okay, you work full time, you work every day, you need to run X amount of tests every day, test suits or test suites or what they call them. Just run those tests and we're gonna pay you, blah, blah, blah. You keep testing, we're gonna keep paying you. It's not gonna happen. You will not find a company in the market which will say the opposite. Will say, you know what, we pay you for the bug you found. We don't care how you do this, just found it.
Wouldn't it be the same as paying the line of code?
Isn't it the same as paying per line of code? We will discuss it tomorrow about paying per line of code, which I believe also is a good idea. You laugh now, but tomorrow we'll discuss it why I think so. I think that...
How about the bug bounty programs, by the way? I think they're kind of pay for the bug.
Yes, exactly. Bug bounce programs. Like many companies do this. They just say, like GitHub does it. Yeah, for example. And many people find those bugs, and they get like $1,000 sometimes, $10,000 for bugs.
It's usually in security field.
Usually it's about security. Yeah, it's usually about security. Well, because functionality bugs they get found by users much quicker than these any bounty programs. Because bounty programs they stay for months, sometimes for years. So they just announce. Big company can announce, break my Windows operating system, find the find the bug there, security bug. Well, Windows probably doesn't do that, but find the bug there and we're gonna pay you. That's exactly the same, but we can make it more routine. And then another quote, which is also interesting, another from a really good book, which also you have to think about reading. It says that if you give programmers a task, just prove that the product, is it the one? No, sorry, that's another one. That's anything written by the people, not testing something is equivalent for asserting that it's bug-free. That's actually right thinking. So if you ask the tester that we want the code, the product, to be bug-free, so it has to be without bugs, then the tester can say, okay, I'm done. It's bug-free. I didn't find any bugs. And then the question, did you try? Yes, I tried, of course. Prove the opposite. I tried very hard for a full hour. No bugs, done. So if you define the task that the product has to be bug-free, if this is the task for tester, then the tester, the best strategy for the tester is to test as little as possible, because that will produce as little as possible bugs, and that will help the tester to reach the goal faster, to finish the work. That's the quote about exactly that. The probability of showing that the software works decreases and testing increases. So the more testing you do, the chances to show that the product works goes down, because we find more and more bugs. The objective to demonstrate high probability of working is best achieved by not testing at all, just like I said to you. And the final line, all the books, they were quite recent books, but we have this quote which is extremely old, which is 50 years old right now already. So 50 years ago it was said clearly by a famous researcher and programmer, one of the first programmers, that program testing can be used to show the presence of bug, but never to show the absence of bugs. So this quote has to be in your head when you meet testers, when you become testers. And I, again, consider being a tester, like not the tester who's the manual tester. You know, there are manual testers who just click the same button over and over again every day. They just open the same application, they follow the same route, they just ask people to do what the robots have to do. So this is the monkey job, so don't become that kind of tester. But the proper tester is somebody who is finding ways to break the software using tools, using instruments, using automated tools, using some security scanners, and so on and so forth. So because the person who is just a manual clicker, the button clicker, is not interested in finding bugs. This person is interested to wait till the end is over, and then you can go home, but not to find bugs. So I found 4 presentations which I made about this topic or around this topic at 4 conferences over the last 3 years. and maybe even 4 years, which were about software philosophy, testing pitfalls, difference between testing and testers, and so on and so forth. So those are the QR codes. I suggest you to watch them later. Okay, that was it about testing. The next chapter is test-driven development. That should be interesting as well. Do you know what it is, test-driven development? You've heard about it, right? So they say that test-driven development means that you write test first and then you write the code. Okay, let's try to do it and see how it goes. So take a look at the left code. First of all, the question to you, do you know what is the programming language here? Lisp, right? Okay, it's a Lisp, it's a functional programming language, which is very elegant, if you ask me, but maybe not very convenient for somebody who is used to more like C++ or Java-like, Java-ish languages. So this one is, the code is on the left. Well, it's a test. On the test, you see on the left, you see the tests, 3 tests. The first test says, if I call the function f with the argument 1, then the result should be 1. The second test says, if I call the argument, the function f with the argument 2, then the result should be also 1. And the line 3 says, not the line 3, but the line 5 and 6, they say, if I call the argument, the function f with the argument 15, then the result should be 610. Okay, now write a code for it. That's the idea of test-driven development. Say again? Louder.
So I just make ifs to fulfill this test.
There you go. Yeah, the straightforward approach, you just make the if this, right? Just three branches. If input parameter is 1, then return 1. If input parameter is 2, then return 1. But is it the code we're looking for? Probably not. So idea of test-driven development, in my opinion, it's a little bit wrong in this approach. If you do it like this, if you really follow the book, if you really follow the suggestion of the book, then you're supposed to write the code here, which you cannot do because the code it's a Fibonacci number. So the code on the left is testing the function, which is the calculating Fibonacci number. Indeed, for 1 it's 1, for 2 it's 1, and for 15 it's 610. But who knew about that, right? So the function on the right, it's a Lisp code which calculates Fibonacci number. Do you understand this code, by the way? You have to, because functional programming, in my opinion, is the most elegant way of writing code. So at least Lisp, you have to learn a little bit. And actually, learning Lisp, it's a super simple task. You can do it over a weekend. It's a much more simple programming language, in my opinion, than Java and all those C++ and everything, because it has a very simple and very compact syntax and semantics. So everything is a list. And everything at the same time is a function. Oh, that's how I understand it. So on the right side, we define the function. Define, it means define a function. Define function f. Then in the brackets, we say the parameters, so just one parameter. And then cond means condition. So on the condition, we define just a list of if the first one is true, then we return 0. If the second one is true, then we return 1. And otherwise, we return what's on the bottom. So cond basically accepts many parameters, as many as you want, and then it just goes one by one, and the last one goes otherwise. It's similar to switch. I'm not sure about the syntax here, actually. I'm not a Lisp programmer, but... And do you understand why so many brackets at the bottom, on the right part? Why they use bracket? Is it clear for you? Why so many brackets? Because they open those brackets, so they need to close them. So look, when you open the bracket on the left before define, you open it on the left, on the top, and then you close it on the bottom on the right. So everything gets into these brackets, everything. So every time you define something, it goes into open and close brackets. And of course, if you open more, so calculate how many brackets we opened, 1, 2, 3, 4, so we need to close them all on the right side. So that's why a large Lisp program they start usually like normal way, and in the end you're going to see many brackets because they close everything you manage to open at the top. And this is how not maybe all, like maybe Haskell is not It doesn't have this particular syntax, but Clojure, for example, which is very popular JVM-based programming language, Clojure also use the same notation. Also brackets, brackets, brackets. You open many of them, and then you close. That's why sometimes they translate the language, the name of the language, Lisp. Originally, it's a list programming language. List programming, list because everything is a list. But a more, funny translation, it's lots of idiotic, stupid parentheses, something like this. I stands for idiotic, P for parentheses, so it's lots of these stupid, idiotic parentheses. So people make fun of Lisp as much as they can, but still this language is super old and still on the market, and it will be on the market, I think, much longer than Java and everybody else. Okay, now let's talk about test-driven development. So now we just saw an example how this test-driven development is supposed to work, and now read this quote, which is, you can read it yourself. I'm not going to read it out loud. So this guy, who knows who is this guy? You don't know. Who is coding in Ruby? Nobody. Okay, that's a good excuse for us. Because there is a framework called Ruby on Rails. Probably you know about it. So he's the author of this framework, Ruby on Rails. And he's also quite famous in the area of management. So he's a big advocate for for remote programming. So they just, Google this guy. So he wrote a blog post, Test-Driven Development is Dead, Long Live Testing, where he advocates, he says that this idea of tests first and the code next is dead. Instead, we just code what we code, and then we just test it. We just test it manually, or we write some scripts to test it, whatever, but we don't write tests first, because it doesn't make any sense. I mean, this idea is broken, which, in my opinion, not so far from the truth. However, we have another quote from another guy, this guy you know probably, right? I told you about him many times, Robert Martin, who wrote another post after that one, and he said that it would not surprise me if you see one day test-driven development had the force of law. So, and actually I agree with this as well. We will just discuss now that TDD, test-driven development, may be not exactly what these people think it is. So he says the tests, actually not in this case, I don't think he's talking really about test-driven development when test goes first, but the development is driven by tests. So it means the tests are extremely important component of writing code. So we cannot write code if we don't write tests. So let's put it this way. Because this idea of writing tests first and then writing code, in my opinion, just like I demonstrated to you now, it's gone. I mean, it's impossible. It's technically not feasible to write tests first because you saw that. But writing code without writing tests, that's a crime. That's what they say. So if you have a code which is not covered by tests, if you write some function and you don't write a unit test for this function, then you're a criminal. I mean, it is not now the case, but I hope that it will be in some time, maybe in 10, 20 years. So they will make this like a law. They will make it like a regulation. And actually they have some regulations already right now for mission critical software. For example, if you develop the software for some medical equipment, or you develop the software for vehicles, for cars, then you will have to certify your software. And there are standards which will ask you to, there are standards and there are organizations where you submit your software, they check your software line by line, and they will give you the certificate that your software is certified. For example, if you read one of the standards, one of the most popular is ISO 26262, that's the standard, 26,262. That's the number of the standard, ISO. And in this standard, there are many rules for your software. So they say how you're supposed to design the software. I don't remember all those rules, but for example, one, you cannot use recursion. So they say if you develop the software for cars, for medical equipment, for something mission critical, no recursion. Why? Well, because recursion brings more problem to your code and potentially can break code in an unexpected way. So we say no recursion. You want to...
And at the same time, you usually write in C.
And at the same time, you write in C, yes. Sorry about that.
Larger problem, I would say.
Yeah, that's a contradiction, yeah. But that's what they say, no recursion, and many other things. So they expect you to get your software certified. And maybe it is already now, I'm not sure, but definitely it will be in the future, that they will say no unit tests, no certification. So if we don't see a unit test for each function you created, for each block of code you created, then we don't give you the certificate. That's it. That's what Robert Martin is saying, I believe, here. Well, read the blog post, it's quite small. I give you the link here. So we want tests. Let's put it this way. We want tests. Both of these guys, the previous one and this one, they both actually say the same thing. Testing is absolutely important. Test-driven development is something which is test-first development is something which we probably don't need so much. So I will explain you how I do it. This is my approach to test-driven development. I wrote a blog post about it 4 years ago, where I say, this is my idea, that I only create tests later when my users express the need for them by reporting bugs. So look at the diagram. This is how I do in all my projects, and I believe that most programmers actually do it this way. First, I do the code. So I write the code. Second, I finish writing the code without the tests. In most cases, I don't put too much test around my code. I make the first prototype, the first working piece of software, which does what it has to be done, has to do. Then I deploy it. I deploy it to production. I give it to customers. Maybe this customer is me. Sometimes, in most cases, it's me. So I do it for myself. I make the prototype. I make the first product, which is, that big. So I package it. I start using it. So that's called deploy. So try to use it. Does it do what it has to do? So I try to break it, the next step. I put it in my hands, or maybe I give it to somebody, and then they start breaking it. Breaking meaning finding bugs. They break it, and when they break it, when they prove that there's something is broken, then I create a test. So when the ticket comes to me, because every time they break, I ask them, make a ticket. I always ask my users, don't tell me in Telegram, don't call me, don't explain me like this, make a ticket. I probably told you this many times. So every time something is wrong with the software, you don't tell the author, you don't send an email. You go to the issue tracking system, ticket tracking system, and then you submit a new ticket and submit a bug. So you do bug reporting. And in this bug you report something is broken, how about you fix this? You get the ID for the bug, you get the description of the bug. What do I do in response for this bug? First step, I make a test. This is my response to the bug. I look at the bug and I try to reproduce this problem in a test. So I know that if the bug is found by the user, it means that I didn't have the test in this place. If I would have the test, I would not deliver that code to the user, automated test. Then the code would not get to the customer in a broken state. So I understand, okay, we have a bug. It means I missed the test. So my first reaction is create a test. The test which will break the code just like my user broke the code. So for example, I delivered to the user the Fibonacci calculator, and the Fibonacci calculator calculates, number 17th Fibonacci number the wrong way. But it's delivered to the user. The user comes back to me and says 17th is wrong for some reason. It gives me 0, whatever, instead of a right number. So what do I do first? I make a test which calls my function, provides the 17 there, and checks what's the output. And if the output is wrong, then the test should say, boom, red light, the code is broken. That's my first step, first reaction. So and then I get very happy. Every time I manage to create a test which breaks, which is red, my first reaction is happiness. Oh, great! I managed to create a test. I managed to add additional coverage to the code. So I made my test, my test setup much stronger. And then final step, I make the fix. And usually, the size of the test is bigger than the size of the fix. It gets bigger. So when the project goes like this, and this cycles goes like on and on and on and on. So I put it to production. I ask to try it, and people start coming to me with the bugs. Maybe these people, even me. So when I develop in the laboratory, then I can be the bugs producer, or my friend can be the bugs producer. So we make this cycle over and over and over and again. And This is what I see in like, according to my statistics of many years of coding. First, in the beginning of the project, the bug, the tests which I create will be smaller than the code I write to make them green again. But the older the project, the larger will be the tests and the smaller will be the fixes. In a very stable project, when you have hundreds of thousands of lines of code, every time somebody comes to you with a bug, you will spend days to create a test which reproduces this problem. And then you make one line change to fix the bug. You will just see it. So if the product is mature, if it's a large system, which has a lot of, already many hours invested into development, it will be very difficult to write a test which actually catches this bug, which proves in automated way that the bug is there. That will be very hard. So it will be many, many lines. You will write like hundreds of lines. Maybe you will even create some frameworks to do this. You will install some extra tools. You will configure some extra integration testing instruments. You will do a lot of work just to prove that in one line, the bug is there. So the number 5 should be changed to number 6. Because this line stays deep inside in the code. And all the tests are already around this line. There are many tests already written. The product is already tested from so many angles, but somewhere deep inside we know that there is one line from 5 to 6. And in most cases you will be able to spot this line without the test immediately. So if you know the product more or less, the customer comes to you and says, you know what, I click this button, something doesn't work. You say, oh, sure, let me fix this line. No, you don't do it. You make a test first. And then, and for the test you spend 2 days. And that's very annoying, that's very difficult. So the work of maintaining the software, when such bugs, users find such bugs, the maintenance is always about, in my experience, always about writing more tests, which is hard. Gets harder and harder. So the complexity of tests go up, the complexity of fixes go down. Not the complexity of code, complexity of fixes, pay attention. So every fix you make in time will be shorter, and in the end you will fix just 1 line, 2 lines, 1 line, 2 lines. So my motto is, I only create tests when my users express the need for them by reporting bugs. So in the beginning, I don't write tests first. I don't cover my code with all possible tests. This is a waste of time. Because you don't know whether the users will like your product. You don't know whether the product will be needed on the market, whether the product will have enough budget in the future. Maybe you will stop the development in a few months. So initially you do whatever you can, just a skeleton, drop it to the users and see what they say. I mean, it's better not to give it to real users, but to testers, to staging users, to your friends, to yourself. But immediately put it there and then start breaking it. I told you that I know that when I start new product develop, no matter how big it is, it can be a large system, very complex, something, new programming language, I know that I have to make it in 2 days, no longer. So if I cannot make a product in 2 days, then I'm doing something wrong. I should be able to do it in 2 days and package it and say it's ready. Maybe it's doing very few features, maybe it's not working completely, definitely not, but it has to be what I'm expecting it to be. It's a new programming language, okay, it's a new programming language. It understands a few commands. It's a web system, okay, it's deployed, so I can open the website and it shows me, okay, click here, log in and do something for me. And then it has tons of bugs. Then I give it to somebody and see how this somebody react to it and how they use it. And then they start producing bugs and so on and so forth. So, 2 days. Well, I read this philosophy, not philosophy, but this rule from Silicon Valley investors. I don't remember who exactly said that, but they said that if the product cannot be made in 2 weeks by the team of 2 programmers, this is not a startup. So you're doing it wrong. So you have to be able to create the product which you can show to investors, which does what it has to do in 2 weeks of 2 people, 2 programmers. So think about it. Think about the product you create for this course. How much? Of course, we're talking about full-time here, so you obviously don't do it full-time. But if you, in the future, remember that if you, sometime in the future, will do something full-time and you want to show something to investors, if you need half a year and a team of 5 people to create something to show to the investor, then you're doing something wrong. You should be able to show your product to investors in 2 weeks. If it takes longer, then think twice. And this is the numbers which you can go to the blog post which I wrote about that, which says I don't need tests at the beginning of the project. On the horizontal line, you see the timing. This is from real project. This is statistics from real software project done for money. Quite large software project, which we were doing for 2 years. So this is the duration of 2 years. So horizontally, you see the timing. On the vertical axis, you see the percentage of how much percentage the tests take in the code base. So in the code base, in GitHub, you have your code, which is the production code, real code, and then you have tests, unit tests, which are written, which stay into your production code. So in the beginning, there are 0 tests, but the product is there. So in the beginning, we have no tests, there's no need to cover anything. And then, when the project moves forward, we quickly, dramatically fast, we add more tests, because people start reporting bugs to us. They come to us with many bugs, and like I told you, there are many tests, and we write many of them. So the amount of tests grow, like exponentially, because the code is not covered, so we just fastly, the amount of tests goes from 0 to about 30%. And then it slows down. Well, this product is it was not super mature, like just 2 years, because I believe that if we would continue after these 2 years, maybe 3, 4, 5, when the product gets mature, then I think the line will go up again. Because like I told you, the mature products, when the bug is coming, then you need more tests, a lot of tests to write in order to prove the bug. But we didn't reach that point. We didn't reach the full maturity of the product. We didn't go to the maintenance phase, so we just stopped at 2 years. So in the beginning it's 0, then the amount of tests go up, and then more or less stable. You have about 30-35% of your code taken by tests, which is not really a perfect example of perfectly tested system. So in a better system, there could be more tests, maybe 50%, 60%, I don't know. Some people say that tests should be 3 times larger than your code. So it should be 300%. I've heard that opinion. So people say that your code should be only 1/3 of the entire code base. So your tests are like 2 times larger, or 3 times larger, but much larger than the code you write. Another metaphor which I give you before the break is the safety net. You see the picture, right? This is probably you see. That's when people work on the construction, when they build a house, then they put these safety nets around around their work zone. For what? You can understand what it's for. Say again? Exactly, because they can drop something. If they drop a hammer by mistake, then the hammer goes down like far away, and then something can be damaged really over there. So they build this safety net. So very often programmers compare unit testing with safety net. So when you write a piece of code, then you don't want to be careful about, when you finish writing some function, for example, you write the function which calculates Fibonacci number or whatever, some function, very simple one. So you implement it, you look at it visually, you see, okay, it works the way I want. It's a cool function. You put it to production, to the code, it goes to production, then you start doing something else. And you start doing something else, and in a few months, the bug comes to you and says something is broken here and there, so you get back to this function again, you open it up, you already forgot how it works, so you open it up and you start fixing there something. So you fix the bug. Okay, if the function is 3 lines, it's not so difficult, but imagine it's a large function, maybe 100 lines. So you fix something there, but you don't remember exactly how did it work before. Like I don't remember what exactly was the result. Like I run it, so what it should return for these input parameters, what it should return for this input parameter. I don't remember. The time is gone. Even me, I'm the same programmer, but I don't remember. So I have to be very careful if I change this function. I have to be really changing one line in this function. I need to really think over again. Do I really have the right to do this? Maybe I break something. And I don't have the safety net. So things can fall apart. Things can fall down out of my function. If I have tests which are written for this function, then I just open the test, open the function, I run the test, calls this function many times and says, done, 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 everything is good. If I call it with the parameter 1, it returns me good result. Parameter 2, good result. And all these results are perfect. So the function is green, 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 green. All the tests are green. Cool. Then I change one line here. I run all the tests. They're all green. Cool. I didn't break anything. I safely put it to production. If I change one line, I run it again. Oh, this one is red. Oh, there you go. I dropped something. I made a mistake. So I revert it back. I get back to the previous version. I say, okay, I don't touch it because something is going to be broken. This is safety net. So the better is your safety net around your code, the better is your testing coverage. They call it coverage. So the more tests you write, the easier for you as a programmer to write. You know, very often people say that, like in real projects, when you go to real projects and you ask people, do you have unit tests? Do you write unit tests? In most cases, the answer will be no, unfortunately. Just go around. This is the many business buildings around us. Go to companies, ask them, do you write unit tests? Very often they will say, no, we don't. And when you ask why, the answer will be, guess what? What do they answer?
No time.
No time, exactly. We don't have time. They can also say we don't have budget, we don't have money, the customer doesn't like it, we cannot convince our boss that it's necessary, blah, blah, blah. No time. So they say basically, we build this building, but we don't have time to put the safety net, you know, so that's why sometimes the hammer drops down, and then we call the ambulance, we get some dead guy over there, so we spend some time to bring him to the hospital, and then we continue building the house. That's what they do. Or maybe even better example, you know, with this joke when the saw, where you put the gas in there, so you just run the saw and it saws your trees faster, comparing to, you know, mechanical saw. But it's a joke. Then the guy is just using this you know, electric saw or whatever, the saw with the gas, but there's no gas anymore. So they say, how about you put the gas in there so it will be faster? And he says, I don't have no time to go for the gas. Let me just saw it. I mean, something like that. Or maybe the car is broken, you know, the engine is broken, and then we just push the car over the road. How about you fix the engine first? No, we don't have time. That's exactly the same. So having no time for tests, it sounds just ridiculous to me. This is your instrument, so you absolutely must have tests in order to develop. So when you hear this, understand it. I even have a blog post about it. People just don't know how to write tests. That's why they say they don't have time, they don't have money, the boss doesn't like it. They just don't know how. They have no skills. That's it. And that's why they tell you all the reasons. Don't believe that. So now we talk about unit testing and integration testing. By the way, do you know what is the difference? Yes. Can you explain?
Unit tests is their testing for like modules in different independent like frameworks. And integration tests, for example, testing of API, or for example, integration between classes or something like that.
Yes, this is what they say in the book, that unit test is for testing one unit and integration test is for testing like a system together. But in reality, it's impossible to make the clear distinction. I will show you now the code and you will see what I mean. Because, but before we go there, I will give you a few hints of, I actually found it on the blog post by someone, which is really good blog post. So I will summarize you the qualities of your tests. So let's say you write a unit test, just like we did in the example. So you test some function, you design your tests. So there are a few things which you definitely need to remember. Quality number one, your test has to be short. Long tests is a problem, are a problem. If the test is long, nobody will be able to read it later, nobody will be able to support it later, maintain it later, and when something happens to the code and the test becomes red, the test says, I cannot pass anymore, I cannot test, and the code gets broken, then something has to be done with the test very often. And somebody will jump into your test and will try to refactor your test, because sometimes they will be sure that the code works and something is wrong with your test. And if the test is long, they will just throw away your test. This is happening very often. It's happening every day in most projects. People just see the test is red, it was green yesterday, today is red. What do? you kill the test. You delete it. That's it. You delete it from the source code. Most programmers do it like this. Very, very rarely programmers just say, okay, now I will spend some time and investigate what's going on, and then I will fix the code. In most cases, they will just delete or disable the test. You will find many disabled tests in source code repository, which later they call technical debt. Probably you've heard about this. Technical debt is something that stays in your code, in your source code, which is to be fixed later. But nobody ever fixes this, or very rarely. So your code should be short. How many lines? I don't know. I put X here. I don't know how many lines there should be there. But in my opinion, let's say 10 lines, maybe if it's more, then you're in trouble. Of course, if it's 100 lines, then this test will be thrown away sooner or later. The second is it has to be fast. Also very typical, people say it in many books, that your test must be fast. How fast, we don't know. My personal, I mean, of course, it depends on the computer, it depends on the server where you run them, it depends on many factors. So my opinion is that it has to be like milliseconds, 10 milliseconds, 5 milliseconds, instantly. So when you have 100 tests, then you say run them all, and they go through in less than a minute. It has to be fast, like boom, 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 one by one. If the test stays longer, just waits and calculates something and waits for some resources, then this test, again, a perfect candidate for deletion. So it will be deleted sooner or later by somebody. They have to be independent. So independent means that they run alone and in the suite. That means that you get one test, you run it, it says okay. You get another test, you run it, it says okay. But if you run them one by one after another, in another order, it doesn't matter. They work no matter how you run them, in which order.
Kind of as a pure function.
Pure function. Well, ideally there's a pure function, but not many tests will be pure functions. Some tests will touch some files, some tests will create files, some tests will delete files, some tests will write something to the database, some tests will read something from the database. For example, you start testing and your test depends on the database. So in this test, you store something in the database. This test starts and assumes that the database is empty. So for example, it's a very typical situation. For example, you have a test which checks how you can store a new line into the database. So the test starts, just writes the line to the database, then reads back the same line and says, okay, the raw line is boom, boom, I can read, I can write, I can read, then everything is good, green. Another test just goes to the database, saves the line to the database, and calculates how many lines are there. One, it compares with the one, everything is good. Two tests. This one works, but only if this one goes first. Because if you put this one on top, then there will be two lines in the database, and the test will fail. And you will ask, like, why it's happening? Why I run this one alone, and it's cool. I run this one alone, it's also good. When I run them this way, it's also good. If I run them this way, it's not good. I give you a very simple example. You can get it from the code, why it's happening this. But imagine they're long tests. You will have no idea how to fix that. In the end, you just delete them both. That's it. That's what's happening. This is what happens. So they have to be independent. They should not depend on each other. How to make these two tests independent? You clean the database before this test, and you clean the database before that one. In this case, they all have to start with the clean database. So they have to delete everything from the database before they start running. Then you can place them like this. But that will introduce a problem for concurrency. We'll talk about this as well. So this is okay, but this one is not okay.
Maybe you should actually box the database and use some in-memory version.
Maybe you can use separate databases. Yes, that would be also a solution. But if there is not possible, because sometimes it's not possible, sometimes you have a large database in some test server, so all your tests, they must connect to the database. So in this case, what do? You clean up the whole database, then you cannot run them in parallel, because if both of them clean up the database in the beginning, if you run them in parallel, then you understand what's going on. It's going to be, race condition. So this one starts the line, writes the line to the database. This one cleans the database. I mean, they can overlap like this, and then they both will be broken. So that's the question: how to make them truly independent. Second line, portable. So they need to run on your laptop, on my laptop, on the server, anywhere. So they have to be they should not depend on any environment. So for example, a large database, that's a bad example. A good test will never be dependent on a large database staying somewhere. The test can be completely, like a capsule. It should work on everything. Everything that the test needs has to be shipped together with the test. You need a database, so the database has to start together with the test. Careful, this is my definition, I gave this name, careful. Careful means it's side effect free, so you don't leave temp files. So it starts, it does something with the database, for example, it writes the line to the database, but after the test is finished, it has to remove the data from the line from the database. It has to be careful, so don't leave stuff around when you finish. But many tests, people design them the way that they leave temporary files, some information in the database, and so on and so forth. Shouldn't be this way. The test starts and finishes at the same, leaving the environment in exactly the same condition as it was before the test started, which is sometimes not so easy to achieve, actually. It could be difficult to achieve. Another one, they have to be isolated. It means that they don't touch my files, so they don't really make any changes to the things that is around the test, like databases, files, and so on and so forth. So don't crash my operating system. Don't delete files, because actually it actually happens as well. Sometimes I've seen the situations when the test starts and the test connects to production database and deletes the data over there. So instead of going to the test database, the test can go to production database by some mistake and run everything over there. That could be very dramatic. So give me an example of a test, and now you will tell me whether it's a unit test or it's an integration test. Is it short, fast, independent, portable, careful, whatever. On the left side you see the code. On the right side you see the test. It's Java. So the code on the left, what it does, yeah.
Question, when we say short tests, do we mean that my test requires 50 lines, I just factor out some functions and make it readable? Or it's not that?
Well, when we say short, like I said, I don't know how many lines it should be. I mean, it's easy to understand, let's put it this way. It's so short that I can easily understand it in a few seconds. So if it could be just 100 lines, but easy to understand, because these 100 lines is just one big text, for example, like a big just a string, like a big chunk of some text, some text. Or it could be a long, or it could be just 3 lines, but there's so complex algorithm in there that it's difficult to understand. So by short, I mean short to understand. So look at the code on the left. What does it do? Can you explain? Can you explain me what the code on the left does? That's right, it reads the first line of this file. So we assume that this is like class book, so we make an instance of class book, then we say give me the title. It goes to some file, the name of the file is hard-coded. It reads all the lines from these files and then takes the first line of this file and returns it. Pretty simple, pretty easy. Then on the right side we made an implementation of the test, which what it does, it makes the instance of a line 6. Take a look at the code on the right, the line 6. It makes an instance of the book. It reads the title, and then assertion. In the assertion, it compares the title with the expected title. Object thinking. So the test assumes that this is the title in this file. Is it short? I believe it is. Is it fast? No. Why not? Exactly, it could be slow, we don't know. Maybe the file is small, then it's okay. If it's big, we don't know how fast it's going to be. Most probably it's going to be quite slow. Is it independent? Is it really independent from other tests? So what if another test just deletes this file?
What if another test kills the process?
What if another test kills the process? Well, that probably should not happen, but yeah, this is not what independence is about. But I don't think it's independable. Portable, is it portable? Does it have everything to?
It's not portable, but quite independent.
Quite independent.
It is, and it's,
If all my data is resolved for that test, then I can position that.
yeah, because it's not now as uses right.
Maybe you're right. Maybe independence is here, but portability is not, because we need the file to be on the system, right? So the file has to be there. If there is no file, then the test will not run, and we will not know why. Is it careful? I mean, does it leave something on the disk after finish? No, right? It doesn't really make any damage. Is it isolated? Can we run this test in parallel? Probably yes, as long as other tests are also careful and don't kill the file. Is it integration or unit test? That's my main question. What do you think? Is it unit test or integration test? Unit test, right? What about file system, which we use in order to run this test? File system is a pretty large module.
It's not tested. It is considered already good because we need to then we need to test all our languages, frameworks, operating system.
We are not testing nowadays.
So it's not under test. We just rely on.
In my opinion, this is integration test. In my opinion, this test depends on another system, on another module. Exactly, we can say that any test depends on something. Any test will depend on something. Exactly. So that's why I said that there is no hard line between unit testing and integration testing. I would better say we just have automated testing. So saying that something is unit testing and something is integration, in my opinion, is just wrong. It's just misunderstanding of the very idea of testing. Because everything, no matter how much you, I mean, the file, the memory, we also depend on memory, right? So we need some memory to run this test. We need file system, we need memory, we need a number of CPUs. So we need things around us. We cannot just imagine the test which will completely isolate our module and test just the model. Okay, how about this version of the test? I changed the test. Exactly the same code, but I changed it. You see what I did? I made the path of the file a configurable, injectable parameter of the class book. So now the class book doesn't know about anything about the file. So the class book expects the path to the file to be injected, to be provided as an argument of the constructor. And then the test now makes the temporary file, you see? It makes the temporary file, it actually makes this file in a temporary folder. Then it writes the text into this file. And then it asks the book, oh, sorry, this is a typo, so I need to provide the path of the file to the book, right? Here. You know, this parameter has to go in here, which is not now configured the right way, and it compares. So what do you think about this test now? Is it short? It's a little bit longer now, but still short. Is it fast? It's even slower now because we write first.
Is it Stimpy?
In the previous test, in the previous code, we didn't write anything. We only read.
Stimpy in Linux is usually
Yeah, microseconds, but still, it's slower than the previous one.
it's in memory.
Yeah, but still, it's faster.
Writing to memory is faster than reading.
In some cases, maybe you run an operating system where this is not turned on. Maybe it's Windows, maybe it's not Linux, so you don't know. All right. So we don't know, but it's definitely slower, a little bit slower than the previous test because we do writing operations and then reading operation. Is it portable? It's more portable, but it's still not careful. But it's not careful now because it doesn't delete the file there. So we make this temporary file, but we don't delete it ever.
And actually, I think in this case there are binary race conditions.
And now, yes, the
File name is, and that's
exactly. So we have one file name for all tests probably. So now we may have conflicts between tests. So it looks better, but we only make the problem even bigger. How about this refactoring? Now I use the feature of JUnit 5, which is called tempdir. The tempdir provides the temporary directory in the parameter to the test. And then I make the file inside this temporary directory. So JUnit, when JUnit will run my test, it will make a temporary directory somewhere. Give me this location of this directory. I will put some files there, whatever I want, all the temporary files. When the test is finished, JUnit will kill this directory. This is the perfect isolation of tests. And it's provided by JUnit. Any testing framework will give you this possibility to to do this thing. Make sense? So this test and this class, the class is very testable. The test is very well written. That's all I wanted to say about unit testing and integration testing. So there's no hard line between them. Make your tests more isolated, faster, shorter, more careful, more portable, and more independent. That's how you will make your code much more suitable for further modifications and for more tests. Test coverage. So what is test coverage? I made you an example. I took this code from one of my libraries. You can see them on you can click the link and go to the full report. This is just a small snapshot. This is Ruby. This is my open source, one of my open source products. You see that some lines on the left are green, some lines on the left are red, some lines are just gray. What do you think is the difference? And this is test coverage report.
Green tested, red not tested, gray doesn't make sense to test.
Green tested. What do you mean tested? What do we mean by this tested? This is not the unit test. This is like a code.
Like we somewhere have unit tests which involve these papers.
That's right. So when the unit test was running, when the test was going, like being executed, the test was calling my code. And while the code was called, only these lines, which are green, they were actually affected. So they were, the execution, the CPU, the computer was moving through this line. And it was never moved through red lines. Why? Because take a look, it says if something, and then red lines. So it means that we never got into this branch, into this fork. So this condition, which stays on the if, never was true. It was always false. So we run this test maybe many times. We tested this function maybe from different perspective, giving them different parameters, but never, the condition was never true. It means that probably in these lines we have a bug, because no tests were ever proved that there are no bugs. So probably the bugs are there. And of course the gray line means that the CPU was never even able to touch this line, because it's like a syntax construct, and you see and there, the two and contracts. So CPU was never there. It would never touch this line anyway. With test, no test, doesn't matter. So this line is out of coverage. So coverage here is the percentage of green lines versus red lines.
I think so versus all considerable.
That's right. The percentage of green lines against all lines. So coverage in this code, in this particular small example, maybe what, like 40%, right? Like 50, 40, maybe, I don't know. A good coverage is like 80%, 90%, 100%, 150. Well, I'm kidding about this. So it could be up to 100, right? So only all lines can be covered with green. So making your code 100% covered by tests is a very good objective for a developer. When you design the system, then you think about how to achieve 100% coverage, which is difficult to achieve in most cases, especially with languages like Java.
What do you mean by those 6 and 8 lines were never touched by CPU? When it was...
That lines means that these lines do not contain any executable instructions. So on the line 206, we don't have any executable instruction. So the CPU will never touch this line, because this line, for example, the line has comment or something which is not executable. So end is just a closing of the block. So this closing line, it never gets executed. So the block is closed, and then we continue somewhere. So the line with the end is just not executable. No executable statements. That's what it says. No executable statements. So we want coverage to be high, and I found out that the right name is coverage criteria. So actually the coverage can be different. It's not just coverage and coverage. For example, coverage can be function coverage. It means that has each function or subroutine in the program been called. For example, you have 5 functions in the code, and while the test was running, only 3 of them were ever called. Then your coverage is what? 3 divided by 5. Another coverage is statement coverage. This is what we saw right now. That was statement coverage. And actually, we saw not statement, we saw line coverage. Let's see, do we have this? We will discuss it, but probably that was close to this. So statements are the things which, because sometimes they stay, multiple statements can stay on the same line. So in many programming languages, it's possible. So you can put statement, semicolon, statement, semicolon, statement, and so on and so forth. So statement coverage is how many statements we actually managed to touch while we were running the tests. Another coverage is edge coverage. Has every edge in the control flow graph been executed? For example, you say, if A, then go here, else go here. And during the test, we only go this way. Then it means 50% coverage. So we didn't touch the second branch, no matter how many lines are there. Another one is branch coverage. Has each branch of each control structure been executed? This is very close to edge coverage. I would say, correct me if I'm wrong, but it seems like it's very, or maybe it's the same. Edge coverage, branch coverage, I don't know the difference. Condition coverage, and you see there is no line coverage, unfortunately. So maybe I got the wrong, maybe Wikipedia is wrong because I got it from Wikipedia. So maybe Wikipedia doesn't say about line coverage because we just saw line coverage. When you go to this CodeCov tool, then it will show you line coverage, which is something that most people use, I think, mostly. Condition coverage has every Boolean sub-expression evaluated both to true and false. So every time you see a Boolean expression, for example, in your program there's 10 Boolean expressions, then you see how many of them were actually tested for both values, true and false, true and false. The good designer incorporates coverage control in your build and pays attention to all coverage criteria. Again, when you design your software, you make the build, automated build, a script. I don't know which you use, Maven, Gradle, whatever you use for your programming languages. So you make a script which I can click the button from a command line and it will go through all the code, compile everything, run all the tests, run the static analysis, and it must check what is the coverage, how high was the coverage by all these criteria. So if you use some tool, any tool actually will provide you this. For example, in Maven we use JCoco, J-A-Coco, Java Coverage Control. So this tool will definitely allow you to configure in your Maven script or Gradle script how much coverage you expect in order for the build to be green. And you say, for example, if it's less than 80%, you break the build. If it's less than 80% of branch coverage, then the build is broken. If it's lower than 90% of statement coverage, then the build is broken. So a good designer will definitely put this control, this check, into the build automation. A bad one will not do that. Interesting topic, another one, mutation testing and mutation coverage. I'm sure nobody knows what it is. I will tell you this is very funny. Take a look at the code on the left. It's Ruby. The function accepts one parameter and returns n multiplied by n plus 1. On the right side, I wrote 3 tests, 3 unit tests. F of 0 is 1, f of 1 is 2, f of 2 is 5. Good? Covered. The code is covered. Let's take a look. This is what the coverage, what is the line coverage here? 100%, right? Because there's one line, so we definitely touch this line. What is the branch coverage? 100%, there's no branches. What is the statement coverage? 100%. All coverage is 100%. So the code is absolutely amazing. So our tests are absolutely perfect. However, how about we do this? This is called mutation coverage. We create 2 mutants. To create a mutant, there's a special tool for that. So we take the code which we have, and then in the mutant number 1, we change one operator from multiply to plus. So we create the same code, but it's a little bit different from the original code. It's a mutant. And then we create another mutant, number 2, and we also change another operator from plus to minus. So we have 2 mutants of our code. 1 and 2. Then we compile that code and run our tests again. Which mutants will fail? Ideally, they both should fail, right? Because the code is broken, so the test should break, right? So that's the assumption. So if you take the code, the production code, break something, intentionally break something, then at least one test should break. That's the assumption. Now let's see what's going to happen with the mutant number 1.
F0 is still 1.
Say again?
F0 is still 1.
F0 equals 1. So my question is, will all 3 tests pass for the mutant number 1? So which one will not pass? Second one. F1 is not going to be equal to 2. 1 is going to be equal to 3, right? What about the test F2? F2 will pass, F0 will pass, right? So boom, mutant number 1 is killed. They say kill the mutant. We kill it because one of the tests actually raises a problem. What about the second test? The second mutant? 0, 2.
Fails all tests.
None of them will pass.
No, actually, you 1, 1, 3. Okay, the mutant number 2 will also be killed, right? At least one test will fail. Am I right?
Yes.
Yes. Okay, so I'm wrong now about the mutation coverage 50%. So mutation coverage is also 100%. So maybe I give you the wrong example. So in a better example, it will show you that some mutants are not killed. So some mutants will stay alive. So it means that we take the code, we change a little bit the some operators there, then we run all the tests, and all the tests says it's okay, nothing has changed, everything is great. And that means that our mutation coverage is not strong enough. You see the idea?
Basically, mutation testing is the testing of testing.
Is the testing of testing, exactly, yes. Mutation testing is how you check the quality of your tests, exactly. And this is what people say is much stronger than coverage control. Actually, coverage control also check the quality of your tests. Also, if the coverage is 100%, then people say, okay, your tests are good. But many people criticize this for the KPI, like a KPI. They say, no, it's not, doesn't work. I mean, you cannot rely on this number. But mutation testing coverage, that's a much more reliable metric. But it's much more difficult to calculate because it's very heavy. You need to make many mutants and run your tests again and again and again. So how many times you will run your tests? Hundreds.
Next to the many, some members actually have problems with that.
So it's gonna take a lot of time. So mutation coverage, there is also a tool, like there are instruments for that, but they take time, like hours or maybe days. So while your testing can take like, I don't know, 2 seconds or maybe 2 minutes, but then your mutation testing will take you hours, days, maybe weeks, but they will give you extremely interesting results. They will show you where your tests are weak. So keep it in mind, mutation testing is very interesting. Okay, a few chapters and then we're finishing. Automated performance testing. Automated performance is about looking at the code and saying automatically, is it fast or is it not? So let's say you write the function and you write the test. The test will say this function is fast enough. Traditional tools, which you can see on the screen, they will run all the possible load testing, performance testing, everything. So basically what they do is that they take your product, take your software, and try to aggressively, intensively put some load on your product and see how the product reacts. How fast is the response? For example, you're designing the web system and you start Apache JMeter, and for JMeter you say put 100 requests for my web page every second or every minute and see how fast it responds. And then JMeter will draw you the graph and everything like this. But this is, in my opinion, this is very good for manual testers, for people who want to break something. That's very good. So they can run it and then come to you back and say, you know what, if I put 100 requests per second to you, everything is good. If I put 200, then your website goes down. So how about you fix something there? But we programmers, designers, we want something which will stay together with the code before it gets to manual testers. And will tell us that this code is slow or maybe good enough, but when I change it, then the automated test should say, you know what, your code was this slow, but now after your changes, you make it 2 times more slow. Just like with the unit test. This is my code, I write the unit test says, your code works, when I give number 0 here, the number 1 comes back. Cool. But I want another test which will say, I give it number 0, it takes 1 second and returns me the result. Then I change something there, I run this test again, and it says, it takes now 2 seconds, so you broke something. But I want this test to be isolated from the environment. So it has to give me the same numbers on any computer, fast computer, slow computer, super fast computer. How to do that? That's the question. Because we don't want to rely on the speed of the computer, right? We want to be objective. How? I don't know. I mean, I don't know any tools which would do this, but for many years we were thinking about creating something like instructions calculator, for example. So I give you number 0, you return me number 1, but while you were doing this, I was calculating how many times you touched the processor, how many times you touched the memory, how many times you touched the operating system, the file system. Then I put everything together, calculated, and I said, that was 5,000 times. Then you change your algorithm, and now it's 7,000 times. So I say, hey, you made it slower. That's the logic. That would be a very interesting tool to measure performance of any code, of some code. Yeah.
I think the technology is already there because Linux says provided a subsystem and through that, I don't know how to pronounce it, can actually measure how many CPU cycles have the program used.
If you have it, awesome. I don't know anything for Java, so maybe it exists for C.
It's not for C, not for Java. It is.
It's a profiler for like a binary file, yeah.
It needs to be adapted to the program
Yeah.
language. It's not
Right.
solution.
So remember that this problem exists. I don't know the solution. Definitely, maybe it exists. Maybe or definitely, I don't know. Find it out. It's a very interesting direction. We have a few more minutes, then we finish. Behavior-driven development, interesting concept, which I use it, well, but I don't use it according to the model. So the concept is this. The business user knows what needs to be done, and the business user, the user who is not a programmer, writes tests. Not we programmers write tests, but the business user, in plain English, write tests. And in the plain English, the user says, when I open the web page, and I enter my name into the form, and I click login, then the next page contains my name in the right top corner. That's the description. But the language which is used there is not a plain English, not like freestyle language, but the language has to be understood, understandable by a computer. So the computer takes this language, understands it, converts it to unit test, and runs it. So for the business user can read the text easily because it's like, it's like a plain text English for the business user. But the computer understands what was meant there, translates it, and makes the unit test. This is a business-driven development. Behavior-driven development. So we put the behavior there, or maybe you can call it business-driven development. So you put the behavior into the file, and then from this behavior, the unit testing is generating, the test is generated. Okay, my final point, which I wanted to make, but we don't have time, unfortunately, it's about quality assurance and testing. I give you the link to the presentation, to the speech, which I made a few years ago at a software conference. My point was there that quality assurance is not testing. So when they call you, when you see the job description that we are hiring QA engineers, you can just understand that these people don't know what they're doing. So QA engineers, they don't test software. They don't write automated tests. They don't try to break software. They do completely different things. They control quality about the entire development process. They control quality. And how it's done, watch the presentation. Maybe now it's not enough time to discuss it, but just remember that QA and testing, completely different things. So prepare for this confusion, which you will hear a lot from many companies. They will try to hire and say, you're going to be QA engineer. In most cases, they give you the title like this because they feel ashamed for saying that you're going to be the tester. So instead of saying, hey, you're going to be the tester, you're going to test the software, because this job description, tester, is very declassified now, degraded now in the industry. So many people believe that the tester is somebody who is out of a college, out of the university, who deserves to get twice as little money as the programmer. So okay, you're the tester, so you do the routine like manual work, And that's why, in order to a little give you more appreciation, they say, no, you're not a tester, you're a QA engineer. So that's how they do it. But in reality, you'll be just a tester. Okay, so what to read? These two great books. Definitely the book on the left by Glenford Myers, absolutely my favorite book. I read it many times. The book on the right is Test-Driven Development. It's classic, by Kent Beck, who basically was the inventor of the term, the concept. Definitely not the inventor of the idea, but the inventor of the the words, the title. If you want ever to publish something in the area of software testing, then this is the conference to go. ISSTA is #1 A-class conference about testing and everything which is computer science and testing. Not just programming, but maybe some of you will become researchers, so I'm giving you this. Call to action, what do? I suggest you to integrate mutation coverage control into your build. You will have a lot of fun doing this. Just find the tool, integrate it, see the results, spend a few hours on running it, and then see the output. You will definitely have fun. Okay, then unanswered questions in this area. #1 is how to test performance right. We already discussed this. I don't know the answer. Maybe you will find out how we can test automated, how we can automate performance testing. #1, #2 is how to create tests automatically. It's very also interesting topic. How can you look at the code and make the tool which will read the code and generate tests? So the tool will write your tests, not you manually, but the tool will look at your code and make tests for you. How to do that? There are many people try to do that, and many solutions actually on the market. Try it out for your language. They may also exist. Question #3, how to motivate programmers write tests, because most programmers still don't do that. And that's maybe the management question, or maybe it's a technical question. So how can we motivate people to write? I don't know. And the last one, how to control the quality of testing. Like we discussed, mutation coverage, test coverage. So let's say we have a team, you're the designer of the team, you have 10 people working with you. So your job is to control that they actually write proper unit tests. They actually test the software properly. How do you do this? That's a big question for you to answer.